Welcome to day 9 of your Python journey. Today, we're exploring how Python handles numbers and logic, two pillars that power every program, from simple calculators to advanced AI systems. You'll learn about integers, floats, and Booleans, the three core data types that form the building blocks of computation. By the end of this session, you'll understand how Python performs math, maintains precision, and even makes decisions based on logic. Let's begin with integers, whole numbers with no decimals or fractions. Think of integers as things you can count: the number of students in a classroom, the year you were born, or how many floors a building has. They can be positive, negative, or zero, but they're always complete numbers. Here's an example. We assign year the value 2025, temperature the value -10, students the value 42, and debt the value -15,000. In plain English, you're creating labeled containers that hold these values in memory. And in Python, there's no limit to how large or small an integer can be, so you can work with astronomical numbers without worrying about overflow errors. Now, let's talk about floating point numbers, or simply floats, the kind of numbers we use when whole numbers aren't precise enough. Think of a thermometer showing 36.6 degrees, a price tag reading 19.99, or the mathematical constant pi, approximately 3.14159. All of these are examples of floats, numbers that contain a decimal point. The term floating point comes from how computers store these numbers. The decimal point can float, moving left or right to represent very large or very small values. That flexibility allows Python to handle everything from the distance between galaxies to the width of a human hair, all with remarkable precision. Let's look at a quick example. We set price to 19.99, pi to 3.14159, body temperature to 36.6, and speed of light to 299.458. In plain English, floats are used whenever you need exact measurements, things like prices, scientific calculations, or temperature readings. If there's a decimal point, you're working with a float. Floats are everywhere in real-world AI and data science. They help in financial models for interest rates, engineering applications for precision measurement, and scientific computing for constants like pi or Euler's number. Now, let's talk about Booleans, the data type that represents decisions, true or false. You can think of Booleans like switches that are either on or off. For example, is sunny equals true? Is night equals false? Has perimeters equals true? And is empty equals false? These are yes or no conditions. In real life, it's like checking if a light is on, true or off, false. A door that's open is true, closed is false. Every program you write uses this logic behind the scenes, from checking login access to deciding how an AI model responds. Booleans are the foundation of every decision your code makes. Python isn't just about logic, it's also a brilliant calculator. It can handle addition, subtraction, multiplication, division, and more. Let's walk through this example. We set x to 10 and y to 3. When we add them, the result is 13. Subtracting gives 7. Multiplying gives 30. Dividing gives 3.33. Notice the decimal, since Python automatically gives you an exact value. Raising 10 to the power of 3 means 10 times 10 times 10, which equals 1,000. The modulus operator gives you the remainder when dividing. 10 divided by 3 leaves a remainder of 1. And floor division divides and then rounds down to the nearest whole number, giving you 3. In short, Python handles arithmetic like a pro, from school-level math to scientific calculations. Here's something smart about Python. It automatically preserves precision in your calculations. When you combine integers and floats, Python converts the result to a float, so you never lose accuracy. For example, we set x to 5 and y to 2.5. When we add them, Python automatically converts the result to 7.5, a float. It does this behind the scenes, promoting integers to floats when needed. You can think of it like automatically converting pounds to kilograms to make sure your measurements stay accurate. Python handles that conversion for you. Booleans might look simple, but they drive decision-making in artificial intelligence. Every if, this, then that statement relies on Boolean logic. Here are some examples. If data is loaded, start training the AI model. Otherwise, show an error. If a user is authenticated, display their dashboard. Otherwise, send them to the login page. If the model's confidence score is above 85%, use the prediction. Otherwise, request human review. In plain English, Booleans help AI systems decide what to do next. Every intelligent action in software, from chatbots to self-driving cars, starts with these simple true or false checks. Let's wrap up what we learned today. Integers are whole numbers, perfect for counting or indexing. Floats are decimal numbers, used for precise values like prices or scientific data. Booleans are true or false values, essential for logic and decision-making. These three types form the foundation of Python programming. Now that you understand how Python handles numbers and logic, you're ready to move to the next big concept, strings or text in Python. In Day 10, we'll explore how Python works with characters, words, and sentences to make your programs more human-friendly. Until then, practice mixing integers and floats and try writing a few true or false conditions yourself. You're doing great. Keep going, and you'll soon be coding like a pro.